Hi guys, and welcome back to another Study Clicks video. Jenny here, and today we're going to be taking a look at the 2020 higher level paper 1, and we're going to be looking at question 3. So question 3 covers the topics of functions, specifically going into some composite functions and also looking at some log rules. So let's get into it.
So this is a functions question. Overall, the question is worth 25 marks. And it's split into, I guess, 3 parts, 2 parts really. So we have part A, a part B, which has 2 parts in it then, so part 1 and part 2. So we'll start with part A. Part A is worth 10 marks, and it's on the topic of composite functions. So let's read it and highlight some key information. They give us 2 functions here. So we have f of x is equal to 6x minus 5, and g of x is equal to x plus 5 divided by 6. And they're asking us to investigate if f of g of x is equal to g of f of x. So like I said, we're dealing with composite functions here, right? So a function of a function. So essentially what we do is pretty much just subbing in functions into functions. I'll show you what I mean now. So starting on the left hand side here, we'll do f of g of x first. So let's write down what f of x is. So functions, you know them, they're kind of like, I don't know, a machine, right? We input x, we get out f of x, right? So they're asking us to evaluate f of g of x, okay? So we approach this the exact same way as if they had asked us to find f of 3 or whatever. Anywhere we have an x, we're going to put in 3, or in this case, since it's f of g of x, we're going to put in g of x. So everywhere we have an x, in goes g of x, so this is going to be 6 times g of x minus 5. Lovely stuff. And they tell us what g of x is. We know that g of x is x plus 5, right? So let's sub that in. And we get 6 times x plus 5 divided by 6 minus 5. Simplifying this, our 6's will cancel. So we get x plus 5 minus 5, which just gives us x. Fantastic. And that's the left-hand side done. We're going to do the exact same thing now for the right-hand side. So g of f of x. So let's write down what g of x is. And now we want g of f of x. So everywhere we have an x in our expression for g, we're going to sub in f of x. And we already know what f of x is. They give it to us in the question. It's here. So let's sub that in. So minus 5 plus 5 is 0, so we're left with 6x over 6, which is equal to x. Fantastic. So we get the same thing. So they ask us to write a little conclusion. So we can write x equals x. That implies f of g of x is equal to g of f of x. As required, if you want to write that in, you can. What does this actually mean? So they're not looking for it in the question and they don't ask it explicitly. But when we have this expression here, that is for when you have 2 functions, right? Like f composite g is equal to g composite f. This actually means that they're inverse functions, right? They're opposite functions. So an example of this would be sine of x and inverse sine of x, or x squared and the square root of x are inverse functions. E to the x and natural log, so ln of x are inverse functions. Loads of them. Yeah, so x cubed and then the cubed root of x are inverse functions as well. So most functions have inverse functions. If they're bijective, they do. But again, that's a lot of function theory that is not needed for this question, but is good to know just in general for your exam. And if you should know anyways, if you take a composite function and your answer is x, that means they're inverse functions. That's pretty much what it means. So I'm going to write it down here. They weren't looking for it in the marking scheme. They pretty much just wanted your conclusion to be they're the same, therefore your answers are the same, therefore they're the same. But I'll write it here. So they're inverse functions, or you could write even if you wanted to, that g of x is equal to f inverse of x. So that's the end of part A. That was 10 marks. I think that was a very nice 10 marks in my opinion. All you had to do is they gave you the 2 functions, you sub them into each other and conclude that they're the same thing. Very, very nice 10 marks. Moving on anyways to part B. So let's take a look at what that question says. So part B is split into 2 parts, but it gives us some information for the entire question at the beginning. So it tells us at the beginning, the real variables y and x are related by y is equal to 5x squared. So part 1 says, the equation y equals 5x squared can be rewritten in the form of log to the base 5 of y is equal to a plus b log to the base 5 of x. Find the value of a and the value of b. So you can probably guess for this question, we are going to end up using our log rules from our log tables. So I would say have those handy as we'll be using them a lot. Let's write down the equation that they give us, and we want to get it into this form. So the key principle here that we're working with is that we have an equation. So anything that we do to one side of our equation, we must also do to the other side. So let's just write down that key rule. So this is our rule. So what's done to one side must be done to the other. So any operation we perform on the left, we must also perform the same operation on the right, or vice versa. So the form that we're looking to get is this one here. Log to the base 5 of y is equal to a plus b to the log base 5 of x. So we want a log to the base 5 of y in our expression. So why not? Our first step should be to take the log to the base 5 of both sides. That's exactly what we're going to do. So let's take the log of both sides. So already we have log to the base 5 of y is equal to log to the base 5 of 5x squared. So already you can see we have one term in our expression. We can do a check on log to the base 5 of y. But we have a bit of manipulation to do on the right hand side. And for this we can use our log rules. You might know them straight off. You might need to use the log tables from them. Depends how comfortable you are with logs. But we're going to go to the log tables and see what we can have to help us. Keep in mind here, right? What do we have in our brackets? We have two terms that are multiplying each other. So let's see if we have any rules for terms that are multiplying each other in our log tables. So your log rules are on page 21 of your log tables. We're looking for a log rule for two terms multiplying each other, and it's right on the top of the page here. We have that log to the base a of x times y is log to the base a of x plus log to the base a of y. So we split them. So we're going to apply that exact rule to what we have. So applying that log rule, we have that. So now we're left with two different terms here. Let's take a quick look at them and see what we can spot. So the first term here, log to the base 5 of 5. So we have the same term in our bracket as is our base. So let's look for a rule for something that has the same log base as in its bracket. So we can't find an explicit rule, but this rule here can help us. We have that log to the base a of a to the x is equal to x. So we can write something similar, right? So I'll just write it here on the log tables for the moment. Obviously do this on your question paper. So we have log to the base 5 of 5, but I suppose we can rewrite 5 as 5 to the 1. And since log to the base a of a to the x is equal to x, this means that log to the base 5 of 5 is equal to 1. So on my question paper, I'm going to go up and write 1 for that. Fantastic. And now we have our second term here. So it's log to the base 5 of x to the power of 2. So now we're going to go to our log tables and see if we can find a rule for log of x to a power. And lo and behold, we do. You can see it here in the third row. We have log to the base a of x to the power of q is given by q log to the base a of x. So we bring the power down, so let's go and apply that rule. So that means we have 1 plus 2 log to the base 5 of x. And we're actually done, right? So at the moment, we have, and in our question, we want log to the base 5 of y is equal to a plus b log to the base 5 of x. So they're the same, So that means a must be 1 and b must be 2. And that's the answer to B part 1. So this was worth 5 marks, a nice handy 5 marks, I think, just using your log rules and just doing some simple algebra. Fantastic. Just a quick note, when you are doing the questions yourself in your exam, make sure you write the log rules that you've used on your question paper. Personally, I would. If you are short on time and space, you can probably leave them, but my personal recommendation would be to be as clear as possible as for what you are writing down, just so your examiner can follow your thinking. Fantastic. So let's move on to the very last part of this question, which is B part 2. So part 2, which is the final part of this question, asks us to, hence or otherwise, find the real values of y for which log to the base 5 of y is equal to 2 plus log to the base 5 of 126 over 25x minus 1. Brilliant. Hence or otherwise, so we can use our answer from part 1 if we want, or we can go at it our own way. I'm just going to use the answer from part 1, right? So from part 1, we've figured out log to the base 5 of y is equal to 1 plus 2 log to the base 5 of x. And in this equation, they've told us now that log to the base 5 is also equal to 2 plus log to the base 5 of 126 over 25x minus 1. So that means I'm just going to equate them. So log to the base 5 of y is equal to log to the base 5 of y. So that means 1 plus 2 log to the base 5 of x is equal to 2 plus log to the base 5 of 126 over 25x minus 1. So simplifying this, I'm going to get everything that's a log over to one side, and I'm going to get everything that's a constant over to the other. 2 times log to the base 5 of x minus log to the base 5 of 126 over 25x minus 1 is equal to 2 minus 1, which is 1. Fantastic. So we're going to do some manipulation. You might be thinking straight away now, oh, difference of 2 logs, I divide if you go to your log rules, but we have a coefficient in front of log to the base 5 of x here. So if we go down to our log rules, right, you might be thinking to yourself at the moment, oh hey, I can apply this one because subtracting two logs, but if you notice, they both have 1 in front of them, so we need to get 1 in front of ours first. So the first thing we do is we're actually going to apply this rule. So we at the moment have q to the log a of x, so we're just going to bring our power back in. So we've log the base 5 of x squared minus log the base 5 of everything in our bracket is equal to 1. Now we can apply that log rule. So the difference of, let's say, log of x minus log of y is going to be log of x over y. So let's apply that. So I have now just 1 log altogether on the left hand side, and that's equal to 1. But our x is hidden within our log. So I want to get rid of the log. You can think of it, we want to solve for x. Our x is currently trapped inside of our log. We need to get rid of it so we can work with it. So how do we get rid of a log? Well, we apply the inverse function. So whatever the base of our log is, it's that to the power, right? There's a log rule for this. I'll open it up. So it's this one here. So here we have that a of log to the base a of x is equal to x. So essentially, right, in order to get x, so the argument of the log, you have to apply a to the power of whatever the base of the log is. So we're doing that. In our case, our base is 5, so we do 5 to the power of each side. So on the left-hand side, that just means we're left with what's in the bracket. And on the right-hand side, then it's 5 to the power of 1, which is 5. Fantastic. So I'm going to multiply across by our denominator. And now I'm simply going to multiply across by 5 and bring everything over to one side. That means I'm left with 5x squared minus 126x plus 25 is equal to 0. So you can solve this using the minus b formula, or you can spot this is actually doable by factorizing. So our factors are going to be 5x minus 1 times x minus 25 are equal to 0. So that means we're left with x is equal to 1 over 5, or x is equal to 25. So are we finished? Well, let's go back up to our question just to check. And the answer is no, because our question asks us, find the real values of y, okay? We have x, we now need to get y. They tell us at the very, very beginning of the question that y is equal to 5x squared. So let's sub in our values of x for y and get our two values. So when x is a fifth, we get y is equal to 5 times a fifth squared, which is 5 over 25, which is a fifth. And then for when x is 25, we get 5 times 25 squared, which is 5 times 625, which gives us an answer of 3,125. And we're done. That's the end of the question. So that was worth 10 marks. I think that was a worthy 10 marks. You know, a bit of fiddling around with log rules and some algebra. So overall, I think it's a decent question. Fantastic. Anyways, thank you so much for watching. I hope you found this helpful and looking forward to seeing you in the next one. Bye!